Hello, good afternoon. Welcome to physics tutorial. So the last video we made, we're talking about current electricity. Okay, so today we want to give an example of current electricity. So the other video I made, I explained how resistors in series and then resistors in parallel, and how we arrived at the formula of resistors in series, and also how we arrived at the formula of resistors in parallel. So let's do an example. Now, the example we are going to do, or the example we are going to do today, is going to show us is a combined example for both resistors in series, resistors in parallel, and then how the currents work differently. So this is the diagram we are going to consider today. So calculate the current in each resistor. Now, remember we said that when resistors are in parallel, the voltage across them is the same. So if the voltage across them is the same, it means that the current is different. So the current across this resistor is different from the current across this resistor. And then if the resistors are in series, the voltage across them is different, meaning the current is the same. So the current that is passing through this parallel arrangement is the same current passing through this. So calculate the current in each resistor. So we're going to calculate the current across these resistors. Then the potential difference across the 3 ohm. Now, since potential difference across this is the same, so when it becomes a single arrangement, so they will be sharing the PD of this battery. So the PD across these 3 ohm is what we are going to calculate. And then across the parallel resistor, so the PD across this. So let's look at the first example. Say calculate the current in each resistor. Calculate the current in each resistor. So first of all, we need to find the combined resistance of the circuit. So total resistance, we'll start by finding the combined resistance of this guy before the combined resistance here. Then remember the battery has an internal resistance of 0.5. So total resistance of the circle will first of all be resistance in parallel or resistors in parallel 1 over R plus 1 over R2. So when we make this, then plus this resistor plus R3, then plus internal resistance, which will give us the total resistance of the circuit. So let's begin by doing this. So 1 over 4 plus 1 over 5. 1 over 4 plus 1 over 5. Then our R is 3. Then our internal resistance is 0.5. So when we do this, we are going to have 20 here. 4 here is 5 plus 9. 9 plus 4. That's so. Plus 3 and then 0.5. So here is 9 over 20 plus 3 plus 0.5. But don't forget, the reason why I'm putting this in bracket is because the formula is 1 over R equals to 1 over R1. So when you are done, you take the inverse to get the R. So the inverse of this is 20 over 9, which is for this parallel arrangement. Okay? Then plus 3 plus 0.5. So we can now add it up. If you make this over 1, or we can just say 20 divided by 9 is 2 whole number, 2 over 9 plus 3 plus 0.5, or let's make it 1 over 2. So when we add, we can add the numbers and then add the fractions separately. So 2 and 3 is 5, right? 2 plus 3 is 5. Then 2 over 9 plus 1 over 2. And go up, right? Okay. So our answer becomes 5. This 18, right? 9 here is 2 times 2 is 4, 9. 5 plus, so 4 plus 9 gives us 13 over 9. 13 over 9 plus 1 over 2. 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 13 over 18. So our combined resistance is 45 whole number 13. So that is the total resistance of this circuit. All right. So since we have found the total resistance of the circuit as 5 whole number 13 over, so we are supposed to calculate the current in each resistor. So the total resistance, we are looking at this as one resistor in series with this. So we are calculating. Okay, so having calculated the combined resistance of the circuit, I want you to notice that now, considering this is a parallel arrangement, this is in series with this. Now, when we combine this, it becomes in series with this. So basically, we could say that the current that this battery is dispensing is one. Sorry, this is supposed to be okay. Combined resistance. So let's find the current of the circuit. First of all, using Ohm's law, V is equal to I R. So the V, which is the voltage across the battery, is 6. We are looking for the combined current of the circuit times the combined resistance, which is 5.72. So making current the subject of the equation, we have 6 over 5.72, which gives us 1.05 ampere. Now this is the combined current of this circuit. This is the combined resistance of the circuit. And then this is the voltage across all of this. Now remember the question says calculate the current in each resistor. Now, this battery is giving us a current of 1.05, which is the same thing here. So here is 1.05 ampere. 1.05 ampere. So the current across the first 3 ohm resistor is the same thing with the current of the battery. Now, it is the same current that is dropped across this combination. But then the question says calculate the current in each resistor. So these two resistors are sharing one current. So we need to find the current across this and the current across this. But you can't do that. You need to also know the combined voltage drop across this, because we said that in series, voltage drop in series is different. Voltage drop in parallel. So these two resistors are sharing the same voltage. Combined together are sharing the same different voltage with this. So we need to find the voltage drop across this arrangement. So first of all, find voltage across parallel arrangement, of which we have done it before. 1 over R is equal to 1 over R1 plus 1 over R2, where we had 1 over 4 plus 1 over 5. If you remember, our answer was 20 over 9, which was the same thing as 2 points. All right, so we got our answer as 20 over 9, which is the same thing as 2.2 volts. So you can see now that 2.2 V is the voltage drop across this arrangement. So we're going to use that to find the current drop across the 4 ohms and across the 5 ohms. So how do we do that? Using Ohm's law. So let's start by saying voltage across 4 ohm resistor will be V equal to IR. So the V we are using here is the voltage across the two arrangements, and then the total current, which is this, and we'll find the resistor. So we're looking for I is equal to V over R. So the V here is 2.2 across 4 ohm resistor. So for 2.2 all upon 4. And then you are doing the same for voltage across 5 ohm resistor. You say I is equal to V over R. The same V is 2.2 all upon 5. So we have 0.58 and 0.46 ampere. So when you add the two of them, you discover that you have 1.05 ampere. So for this first one, which is the 4 ohms, we have 0.58 ampere, and then for the 5 ohm we have 0.46 ampere. So we have successfully calculated the current in each resistor. So we said that the current in the battery is the same with the current across this 3 ohm resistor, which is the same current across the parallel arrangement. but we need to know the individual current across the arrangement. So this is when you combine all of this, you get the combined resistance of, the combined current of the circuit. Then the next question says, calculate the potential difference across the 3 ohm resistor. When resistors are in series, the voltage across is different. Now remember that the total voltage in the circuit is 6 volts. So to find the potential difference across the 3 ohm resistor, okay, so we are trying to calculate the potential difference across the 3 ohm resistor and across the parallel resistors. So first of all, let's take the first part. Now the overall voltage of the circuit is 6 volts. We have already calculated the arrangement across this parallel resistor. So what we just need to do to calculate the potential difference across these 3 ohm is just to subtract what we have done here. So we are going to say PD across 3 ohm 3 ohm resistor. So the PD is equal to combined V 6 volts minus the voltage we got here, which was 2.2, right? So when we subtract 6 volts minus 2.2, we're going to get 3.8 volts. So that is the voltage across the 3 ohm resistor. So at this point, I'm going to stop here. The second part of the equation says across the parallel resistor. So you are going to find the voltage across the parallel resistor. So when you get your answer, you post it in the comment section. Thank you for listening.